Okay, let me zoom in on this. Newton's third law. Focus would be good. All right, here we go. So at the top right up here, we're going to write Newton's third law right here. We've done first, we've done second, so this is Newton's third law. And yes, I am going to do these little dots like this. Okay. Does anybody know what Newton's third law is? Alrighty, here we go. We're going to write it right underneath here. When an object exerts a force, so let's write that down. When an object exerts a force on another object. On another object. When an object exerts a force on another object, comma, the second object exerts an equal force, exerts an equal force in the opposite direction. In the opposite direction. So another way to say that is, anybody know another way to say that? Well, you guys are really chatty today. Another way to say that would be, for every action, there is an equal and opposite reaction. For every action. Have you guys heard of that before? Yes or no? For every action, there is an equal and opposite reaction. Bless you. For every action, there is an equal and opposite reaction. I don't have a fun graphic for us yet, but I will. Oh, okay, here we go. Here we go. I can think of one. All right, so let's see. Here is a brick wall. How do you make it look like a brick wall? I'm trying to think. Does that look like a brick wall? Not really. So let's label it brick wall. Okay. And we have a guy or a gal. Gosh, my nose is running. Who is applying a force in this direction. Okay? The brick wall is going to be pushing back with the same force. You don't think of that? You're like, the wall isn't pushing back, but it actually is. All right, now we're going to go to the inside of the flap right here. Okay, I'd like you to write the word right up here, the word momentum. Momentum. M-O-M-E-N-T-U-M. momentum. Okay? And momentum, when we work it out in a formula, of course, it makes sense for it to be a P. Why couldn't we have it be an M? Because we already use M for meters, exactly. Exactly. So when I want you to think of momentum, I want you to think of mass in motion. So would you write in quotes right here, mass in motion? Okay? And then I want you to give me a big arrow right here. It's one of my favorite colors, this yellow. This is going to be the law of conservation of momentum. Law of, and of course you won't be able to see it super well because I'm using this yellow. Law of conservation of momentum. Okay, the law of conservation of momentum states, I'm going to use a darker color for you. Man. Okay, the total momentum, the total momentum, the total momentum before and after collision is not changed. Okay? So far, so good? Yeah, yeah? Okay. So now what I need us to do, let me see if I have my document right here. I don't think I do. Okay, can you draw right here, triangle? So P goes here. What did we say P stands for? So this is momentum. Momentum is measured kilogram times meters per second. It's not squared. Squared is acceleration, so be careful with that, okay? It's not squared. Down here on the left, we have M. What do you think M equals? Mass. So this is going to be mass, and what's mass measured in? Kilograms. Okay? And this down here is going to be V. What do you think that is? What is velocity measured in? There you go, meters per second. So it makes sense that momentum, since momentum, if you cover it up, is this times this would be the formula. It makes sense that it's kilogram times meters per second, right? So far, so good?